So now that we know how to convert the units of length, we are going to look at converting the units of area. An area is just as simple as the length. It only requires a few adjustments, and I'll show you those adjustments now. So let's try and remember what the area is, or let's explain what the area is rather. The area is the amount of surface space you are occupying. So for instance, if I want to find the amount of space occupied inside of this, I would need the length and I would need the width, and I would have to just simply take the length, multiply by the width, and it would give me the area inside of this square. In other words, it will tell me the amount of surface space that I have occupied. Now remember what we did previously when we dealt with square numbers. This is where square numbers start becoming applied. Notice the unit of area when you have lengths in feet and width in feet. You will have an area of square feet. So let's look at counting the amount of squares that we have inside of this shape here. Let's say this area here is what we are trying to figure out, how many squares occupy that space. Alright. The fastest way to do that is by simply measuring the height and the width, or the length and the width. And the length, we would see 1, let me write that in different color, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. We see that we have 5 high by 6 wide, and we say that okay, 5 high by 6 wide will just give me a value of 30. 30 what? As I said before, we need to have a context. We need to be able to have a scale and a context, and 30 does not give us a scale and a context. Let's see if we can get some context from the units we have. Notice this unit here of meter, this unit here of meter. It says that each one of these little blocks inside of here has a height and a width of 1 meter. 1 meter multiplied by 1 meter will be equal to 1 meter squared. Now this is something that we saw earlier when we did square numbers. We said that whatever your height is and whatever your width is, you just simply square the values and you'd get that. Now I know how to work this out. We will first separate the numbers and then work with the letters. If we separate the numbers, 1 squared will be 1, and nobody in their right mind can tell me what m squared is. So I will leave it as m squared. Alright, we don't know what it is, so we'll leave it as m squared. And we see that we have 1 meter squared. That means this area inside of here is 1 meter squared. If I have 30 of those 1 meter squares, then what it means is that I have 30 meters squared. Now, this is how you go about establishing your units. And you will see more about it and understand it more when you do algebra later on. But I want you to see right now how we develop these units. We are simply now talking about a scale and we are gaining a context. We know that our scale is 30 meters squared in size. 30 meters squared in size, and we are able to understand that it is an area because we have m squared here. M squared simply tells us area. So we have already done measurements. We've done measurements in meters, centimeters, millimeters, and kilometers. Now what we have to do is recognize that those measurements were for distances, lengths. So if it is that we want to have the area, and we recognize in the previous part of this lesson that for getting the area we simply square the unit. So we take the meters and we just simply square it, we get meters squared. We take the centimeters, we square it, we get centimeters squared. Millimeters squared, we get millimeters squared. Kilometers squared, we get kilometers squared. Since we have to look at the values for the conversion rate, let's start off with first kilo. Kilo, which we recognize as 10 to the power of 3 or 1000, can now become 10 to the power of 6. Why? Because we have 10 to the power of 3 squared. 10 to the power of 3 squared means I'm taking 10 to the power of 3 and multiplying it by 10 to the power of 3. Okay, 10 to the power of 3 is 1000, then 10 to the power of 3 again is 1000. And if I was to look at that, I would see that I would end up at 1 million. 1 million is what? 10 to the power of 6. In other words, a 1 with 6 zeros. And that's all we have to do. Just simply take the prefixes that we have previously and square them. So hecto, 10 to the power of 2. We now take 10 to the power of 2 and square it. We get 10 to the power of 4. Deca, 10 to the power of 1, which represents 10. We take that 10 to the power of 1 square root, we get 10 to the power of 2, which is simply 100. So let's look at this and see how we can try out this little knowledge that we gained here. Let's simply convert the square millimeters to square centimeters. To do it, the first thing that we have to do is recognize that we need to get rid of the milli part. So let's say 25 millimeters squared. We have to get rid of the milli part. Let's remember what milli stands for. Milli is 10 to the minus 3. If we are dealing with millimeters squared, then this means we have to have a square value here. Now we just simply have to multiply these two values here to get the answer, but it's 10 to the power of minus 6. Okay, if it's 10 to the power of minus 6, then all we have to do is just take that 25, multiply by 10 to the power of minus 6, and that answer would be in meters. Now all we have to do is just simply divide that result by the power that we want to convert to. We want to convert to centi. Centi is 10 to the minus 2. Squaring of centi, since we are dealing with area, will be equal to 10 to the minus 4. We have 10 to the minus 4 here. All I need to do is type these in on a calculator and I'll be able to get my answer of 0.25 centimeters.